Oxidation is about oxidation reduction. Titration is another titration, so it's like kind of volumetric analysis. But in this case, it's not acid-base, so it's not a neutralization reaction. It's oxidation reduction reaction. So what is happening in this reaction? Of course, the reaction is a redox reaction. We are going to perform titration. We are using burette. We are using pipette for exact measurement of the volume. And we are going to, most of the oxidation reduction reactions, they are not one-to-one ratio. You have to have the balanced equation. And if the equation is not balanced, you need to balance it. When we are balancing oxidation reduction, you have to balance it based on the ions and electrons. So you have to balance the charges as well. If you balance the equation for half a reaction for permanganate is going to go from MnO4 minus to Mn2 plus. It is half a reaction. So it needs to be balanced. If it comes in permanganate, you see we are missing oxygen. So we add 4 water to the right side because we have 4 oxygens. And then we have 8 H plus to the left side because we have 4 H2O and it's going to require 8 hydrogens. Then if you look at this, we have 1 minus and 7 plus. That gives 8 plus, that gives 7 plus. Is going to 2 plus, 7 plus going to 2 plus. The charges must be balanced. That's why we have to add 5 electrons to the left side. So we add 5 electrons. So then for half a reaction of oxidation, when we have the oxalic acid going to CO2, it does require 2 electrons after you balance everything. It requires 2 electrons because you get 1 carbon. Here we have 2 carbons, so we have to add 2 CO2. When you add 2 CO2, oxygen carbon is balanced. We have to balance then the charges, and the charges, you have 2 negative charge. On the product side, you have to add 2 electrons to balance the oxidation half. When both oxidation half and reduction half are balanced separately, then you are going to add them together. How do you add them together? You see where the arrow sign is for both of them? Where this arrow sign is, you are going to draw one of these arrows on the okay, you would sign one of these arrows. And anything to the left of the arrow are reactants. So you're going to bring, you can cancel or simplify if you can, and add the rest. And then you would add the product side, all product side to the product side. Before you add this, I have to take you one step back. Before you add this, can you, if you add these two, electrons do not add. What happens to electrons? Electrons must be canceled before you add them. So you have to multiply this small half a reaction by 2 to get 10 electrons. And this half a reaction, we are going with the least common multiple. This half a reaction by 5 to get 10 electrons. So 5 times 2, 10 electrons would cancel. 2 times 5 would be canceled. But this is going to give us 2 permanganate, 16 hydrogen, 2 manganese 2 plus, and 8 of the water. And for the bottom one, you get 5 oxalate ion and 10 CO2. So the electrons would cancel each other. When you get the balanced equation, after you cancel the electrons, add the 2 half reaction together, we see that for every 2 permanganate, we need 5 oxalic acid, or for every 5 oxalate ion, we need 2 permanganate. So the ratio for this reaction is 2 mole permanganate for every 5 mole of oxalate. And we are using this ratio for our conversion factors. So if we have the moles for manganese and we want the mole for permanganate for the oxalate ion, we would multiply by 5/2. So that ratio is either 2/5 or 5/2, depends on which you want to convert to and which one you're converting from. So the type of calculation that you get in this experiment, there are two types. One is to calculate molarity of oxalate solution. To calculate molarity of the oxalate solution, if you have the molarity of permanganate and the volume of permanganate, then you can do it. So is titration. You have volume and you have molarity. So from that, you need to calculate the molarity. So number of moles for permanganate is going to be molarity of permanganate times volume of permanganate in liters, expressed in liters. So molarity times volume, this would give the moles of permanganate. But if you want the moles of oxalate, every 5 mole of oxalate, it's 2 moles of permanganate. So you have to multiply by 5/2. And that would give you the moles of oxalate ion. Molarity for oxalate ion, because that's what we are trying to figure out, is going to number of moles of oxalate ion divided by liter, or the volume of oxalate solution in liter. If you were using 25 milliliter of the oxalate ion, you just put this one as 0.025, but pay attention to procedure in the lab manual if you were using 25 milliliters. And you can calculate the molarity of oxalate ion. So why do we need the titration here? We need the titration because we are going to start with 25 milliliter of the oxalate, but we don't know how much manganese, how much of permanganate is needed to neutralize this, because we don't have the concentration for oxalate ion. If it's asking to calculate molarity of oxalate ion, that means we don't have the concentration for oxalate ion. So we are going to use the titration to see how much permanganate was needed to neutralize the oxalate ion. And if our permanganate is a standard, so we have concentration for permanganate, the volume used, again, we are using burette. So the volume used is going to be the initial volume minus the final volume. So we use the volume of permanganate is a V final minus V initial. So we have the volume, we have the concentration for permanganate. This ratio, don't forget about this ratio, because it's not 1:1 with oxalate. It's a 5:2 ratio with the oxalate. If you have the moles of permanganate, you must multiply by 5/2 to get the moles of oxalate ion. One unique factor about this reaction is that the permanganate is purple color and the product is colorless solution. So as you add permanganate, which is the purple solution, into the oxalate, which is colorless, when the reaction takes place, the products have no color. So the color would disappear. So in this case, we don't need indicator because one of the reactant is purple color, but the product is colorless. At the moment that all of oxalate ion is reacted with added permanganate, you're going to add extra drop of permanganate, purple color would stay, and when the purple color would stay, then is endpoint of the reaction. Endpoint of the reaction is going to show by color change, and that means the number of moles of the oxidation of the compound being oxidized and the one being reduced are going to be equal based on the stoichiometry of the reaction. If the balance equation, it says that you need every 2 mole of permanganate needs 5 mole of oxalate, that is the ratio you are using. So no indicator in this reaction. The reaction is going to start slow because we do need the, it's a slow reaction to begin with. But when the manganese Mn2 plus, when it's created, that is going to be acting as a catalyst. So the reaction would move fast after the first few drops. But the first drop definitely is going to be slow reaction. So you can find the concentration of oxalate ion. If you do the titration, you find the volume for permanganate, you have the concentration for permanganate. Use this equation number 5. In the lab manual also is equation number 5 and 6 for that. You can also find the molarity of potassium permanganate. If your potassium permanganate is not standard, you would use sodium oxalate. And with the sodium oxalate, you can do the titration just like KHP. You measure the mass of sodium oxalate, you dissolve in water, add enough permanganate until it's neutral. Then you find the moles of sodium oxalate. Because it's a solid compound again, moles of sodium oxalate is going to be mass divided by molar mass. Mass divided by molar mass. When you have the moles of oxalate, then you would use the ratio 2 moles of permanganate for every 5 mole of oxalate. So you can find the moles of permanganate. When you have the moles of permanganate, you divide by the volume of permanganate used. Let's say in this example, you have 32.47 milliliter of permanganate is used. You convert this to liter, it's going to be 0.03247 liter. So when you find the moles of permanganate, you divide by this number. To find the moles of permanganate, you need to start with the mass of oxalate ion. You divide by molar mass of oxalate ion. I know this is going to give you the moles for oxalate ion, but then you multiply by 2 moles permanganate, divide by 5 moles of oxalate. That is going to give you moles of permanganate. So let me show you here, moles of the sodium oxalate times 2 mole of permanganate over 5 mole of sodium oxalate. That would give you moles of permanganate. When you have moles of permanganate, you divide that by liter of potassium permanganate solution, which you found from the burette, how much was needed. That gives you the molarity. If the volume is in liter, that would give you the molarity.